Good day, ladies and gentlemen. Welcome once again to our system administration subject. This topic is all about DNS, or the domain name system or domain name service. It is an essential part of a network, specifically in an enterprise network. It could also be an essential part of a small home network. So the domain name system is used to resolve host names to IP addresses and vice versa. If you type in your domain name in your web browser, this application will translate those domain names, like say for example google.com, to IP addresses in which the other devices on the other end can only understand. We use domain names like say for example google.com because it is easier to remember than an IP address. It is easier to remember google.com instead of its IP address. Let's say for example 8.8.102.8. For example, any human being can attest to that it is easier to remember uh, like human readable uh, things instead of numbers. And maintaining, configuring, and updating is one of the essential function of a system administrator. So let's say this is a user and he intends to go to a website called davis-hamster.com. Okay. So he uses Google Chrome, Firefox. The first thing that the system or the network will do, packet will be sent or data will be sent to a DNS server. The DNS server then translates the, the website into an IP address. It sends data to the user in which it will tell that, hey user, the IP address of the website that you are trying to access is this one, 205.25.111.6. Okay. The user then sends an HTTP request to the corresponding IP address of the web server of davis-hamster.com. And the web server then saves the website as a sort of an HTTP response to the user, and then the user can browse the website. Okay. So that's how DNS works. That's how you browse something. You browse a website. That is the analogy of a DNS system. Okay, so for our testing configuration, we will use this virtual machine setup. We will use two virtual machines, in which the first one is the DNS server, the second one is the client. Okay, we will use two Ubuntu Linux machines as our virtual machines. For the first virtual machine, adapter 1, we will configure the adapter 1 as NAT, and adapter 2 is internal network, or it could be host only adapter. It depends on you. For the client, we will use one adapter only. Okay, so once again, for the server, VM1 NAT, and adapter 2 is internal network. For the client, it's only adapter 1. So you configure the IP address of the virtual machine 1, in which we'll configure the DNS server. Let's say this is the configuration. It has a specific IP address which is found on the bottom of ENP0S8 configuration. After you have configured that it has two IP addresses from ENP0S3 and ENP0S8, we can then do these two commands. Okay, sudo apt update and sudo apt install unbound. So the first command will update the update servers of the Ubuntu client that you are using, Ubuntu server that you are using. This command will connect to the internet and it will get all the update files from the server of Ubuntu, the nearest local server of Ubuntu. If there's a need to update, if there's a need to upgrade, you should first issue this command. The second command will install the Unbound application. The Unbound application is the equivalent of our DNS system. We will use this application, we will configure this application as our DNS server. After it has been properly installed, we edit this file, unbound.conf, which is located in /etc/unbound. We do sudo apt update and wait for the update or the downloading of the updates to finish. This should only take around a couple of minutes. And then when it says it's done, it's already done updating. It has downloaded the necessary, it has downloaded update configuration from the Ubuntu servers. So let's now do the installation of the Unbound software or application. After this operation, you click on or you type yes, and then it will download the necessary files in which Unbound can run on this specific Ubuntu or Linux server. So there should be no errors on the application. There should be no error messages that will be displayed on the screen, and that means that your installation has succeeded. So we now edit this file unbound.conf, which is located in /etc/unbound, by doing this command, sudo pico /etc unbound.conf. So this is the only line that is currently embedded or inside this unbound configuration file. We add these lines and this also for the Unbound configuration to work. So I added all the configuration that is necessary for our DNS server to work. So let's now discuss some important configuration that must be configured in this particular file. First one is this one, interface. This should be the interface in which the local area network is attached to. So our local area network is attached to the ENP0S8, so that is why you type in ENP0S8. For our port, the default port of DNS is UDP 53. So we type in 53. Next configuration is the private addresses. Okay, This is the sample of our private addresses that will be configured. Okay, so this is the private addresses that is connected to our local LAN, local IP addresses that is local connected to our local area network. Next configuration is control which clients are allowed to make recursive queries. We allow our local area network to make recursive queries. What is recursive queries? It is when the DNS server of your local area network will do queries from other DNS servers if the IP address or if the domain name is not in its cache. So let's say google.com is not found in the local DNS server. It will search the internet, search the other DNS service providers to check if there is google.com in their DNS servers. Your local DNS server will do that by itself. Okay, you don't need to do anything. You don't need to tell your local DNS server that, hey, DNS server, this is not found in my local DNS, please do it, please search from other DNS servers. Okay, so your local DNS server will do that for you. So that is recursive. So now let's go to our local zone. This is our local area network domains. Let's say, for example, we are setting our local area domains as estroga.lan or my family name.lan. So if I have a web server inside my network that corresponds to estroga http dot colon slash slash www.estroga.lan, it will be sent to that specific web server. So for our configuration, we set this as an example. Next is we set this server, this particular computer, this particular server as our DNS server. Okay, we assign it an IP address as this one. We also have a client, another server, or another entity, another workstation, in which we assign a domain name of client.estroga.lan, and it has an IP address of 56.201. Our third server, we have a server called file server that is estroga.lan, and we assign an IP address of 56.202. The next configuration is for the pointers. Okay, so if our DNS server says that, hey, you're trying to access file server that is estroga.lan, and this of 192.168.56.200. So this is your IP address. You go to this IP address, DNS server. It will be automatically forwarded to file server that estroga.lan web server or any other server. Okay, so these are pointers for a particular domain name to the specific IP addresses that it is assigned to. Okay, so this configuration will allow this DNS server to search other DNS servers in the internet if a particular domain is not found in its local cache or local DNS servers. Okay, so that is our configuration. Let's just verify if I have changed already my IP address. I have not changed my IP address yet. Let's just change for a while. I'm going to add ENP0S8 here as our secondary IP address, to which is located in our local area network. Going to verify, we have two IP addresses already. This is the first one. This is connected to the internet, which says it's configured as NAT. And our third IP address, second IP address, 56.200, it is linked to ENP0S8, and it is connected to our local area network. So to check for errors, we do this command sudo unbound check conf if there are configuration errors that we have done in the unbound.conf. Okay, it has checked already, and it has message that there are no errors in the unbound configuration file. Let's do some further configuration for this DNS server to work. Let's open this file, sudo pico /etc/sysctl.conf. Okay, let's do this file. Let's open this file now. Sudo pico /etc/sysctl.conf, and at the bottom we will add this two lines. Okay, netcore rmem net.ipv6.conf all.disable.ipv6. This essentially disables IPv6 connections to this particular unbound or DNS server. This will also add this configuration, and after adding this configuration, we will save it and then do this command, sudo sysctl-p. This will apply all the settings that we have just configured in this file. Sysctl sysctl-p. Okay, so once you see this message, it means that the new configuration has been updated and already implemented in your system. Let's restart our unbound server, our DNS server, so that all the settings that we have done will be implemented. Okay, and then let's edit our UFW, our firewall, to allow port 53 to access our DNS server. Okay, we allow DNS incoming and outgoing packets to be sent to this particular IP address. Okay, so sudo UFW allow port 53 UDP, and then we enable our UFW or firewall. So if we view our firewall, you have seen that port 53 and port for version 6 IPv6 has been allowed, and anyone in our local area network can access, anyone from the internet can access our DNS server. Now let's set up our client virtual machine. Client virtual machine. So let's say this is my client virtual machine. I'll just verify first if internal network I'll make this first host only adapter so that it will boot fast. So the next process is we will test our virtual machine. We'll test our DNS server. While waiting for our secondary virtual machine to boot up, let's check if our DNS server is running properly. Okay, our Unbound DNS server is active running, and this means that our DNS server is working properly as expected based on the configuration that we have done a while ago. So there are no errors. Once again, this should be active running. It should be all green. Active running is also green. Okay. If you see active but exited, that is, so there's something wrong with your DNS server. If it's not this, if you see disabled, that is also not running. So to exit this one, we type in Control C, and now let's double check our secondary virtual machine. Let's log in first, and then change our network settings to internal network. Let's check our configure our IP address. Our our secondary IP was assigned 56.201. Let's type in 201, and we'll implement the changes. So the IP address of the second virtual machine is already 56.201. And now we will set the client's DNS resolver into the IP address of our virtual machine 1, which is the Unbound DNS server that we have just configured a while ago. This setting will force the secondary VM to query the local DNS before querying other DNS servers. So let's now open this file. Sudo pico /etc systemd resolve.conf. Okay, so look for the line that says DNS, uncomment it, and then add the IP address of your local DNS servers. For our test configuration, the IP address is 56.200, and then we save it, and then we will restart the resolve service with this command: sudo systemctl restart system resolve systemd. Okay, systemd. So this should be systemd. Okay, systemd-resolve. So we will now check the status of our resolve CTL to verify if the settings that we have changed has took effect. It will also determine the DNS servers that the VM number 2 is connected to. Okay, we do this command: sudo resolve CTL status. So we have now verified that our current DNS server on VM number 2 is 192.168.50. 56.200. The DNS servers is 56.200. So to verify if we are connected to the VM number 1, we'll do ping. It's connected, and it means that we are connected to our local DNS server. So we will now do some tests on our virtual machine VM number 2 to check if it can resolve domain names from our local LAN. We'll do this dig at 192.168.56.200 to check if this local DNS server is working. Okay, if you see these replies, it means that your DNS server is working properly. Your client's DNS resolve CTL is also working. So let's test an outside domain. Let's say dig metro cdodev.com. So this is a website, and check. So it has answers. metrocdodev.com corresponds to the IP address 192.0.78.218. Okay, this is the IP address of this website. Let's do another example. Dig, let's say, google.com. Okay, so google.com's IP address is 142.251.220.238. Okay, so you can see here in the answer section, google.com, and then its corresponding IP address. We will also test our local domains. We have configured local domains a while ago, in which every time a client will try to access computers, servers in the local area network, we can use domain names instead of IP addresses. We can use this command, dig, and then what is the domain name of the local computer, local server, then we do plus short. Okay, so dns.estroga.lan is connected to the IP address 192.168.56.200. If we say dig file server estroga.lan plus short, so I think this is also correct, 56.202. You could also test for the PTR records for correct domain name. So let's say you only have an IP address, let's say 192.168.56.202, and you want to determine what is the domain name of this IP address. 56.202 corresponds to file server.estroga.lan, and this means that your local domains, your local unbound server, your local DNS server is working properly, and it can get data from other domain servers. So that's all, and thank you for watching and listening to this video, and see you next time. Goodbye.